Good morning, everyone. It's a very interesting and busy morning with the talks that we'll have. Bonjour et bienvenue à la conférence Romanowski. The Miroslaw Romanowski Medal is awarded every year for scientific work relating to environmental problems. The medal was established in 1994 at the generous bequest of the estate of internationally renowned metrologist Miroslaw Romanowski. An annual lecture series for the award recipient is held by the medal winner. Today's lecture will be given by the 2022 winner of the Romanowski Medal and Fellow of the Royal Society, Professor Amar Mohanty. Professeur Amar Mohanty est un pionnier dans le domaine des matériaux, des biomatériaux avancés. Il a consacré sa vie au développement de matériaux biosourcés dans le but de réduire l'impact environnemental des plastiques. Sa vision a déclenché de nombreux changements dans l'industrie et ses emballages compostables primés et ses pièces automobiles vertes ont été largement adoptées par le marché. Cette nouvelle génération de matériaux promeut l'économie circulaire en produisant moins de gaz à effet de serre et de rejet. Professor Amar Mohanty is a pioneer in advanced biomaterial science and engineering. Sorry, it was a long evening yesterday. His lifelong dedication to developing bio-based materials that reduce the environmental impacts of plastics has catalyzed changes across major industry. His award-winning compostable packaging and green automotive parts are commercially adopted in global markets now. They have lower greenhouse gas emission, reduce waste, and represent a model for realizing the circular economy concept for the next generations of material. He has, in fact, a beautiful website on circular economy that I took. Oh, just a second. So a question and answer will be held at the end of the lecture. So there'll be a microphone in the room, and I will try to, Dr. Mohanty will not be able to see with the lights, but we'll try to help you. So ladies and gentlemen, mesdames et messieurs, please welcome Professor Amar Mohanty. Thank you very much.
Thank you.
You okay? I think have you look at that too? Everything's okay? You see?
So thank you, Professor Tremblay, Michel Tremblay, for your excellent introduction. And first of all, thank you to RSC for this honor of Miroslaw Romanowski Award for the year 2021. And I am also thankful to all my previous researchers and students, postdocs, and my collaborators, and all the funding agency. And I'm also very much thankful to the nominator and deeply also indebted for all the referees. So without them, this could have not happened. And at the end, I would like to congratulate all the award winners of this year. So with that note, I would like to talk today on this lecture that I have to give as a part of my Miroslaw Romanowski Award. So as you can see, the title of my today's presentation is Circular Economy Driven, Sustainable Polymers and Composites. Future is now in mitigating climate change. To my background is I am basically a chemical engineering in profession, especially I work in mostly sustainable polymer science and engineering, but most of my research is directed towards more sustainable alternatives than the petroleum-based alternatives. In this whole presentation, I will give you an idea how sustainable plastics is required and what is the importance of sustainable composites are this global climate change scenario. So this global climate change is quite catastrophic, and we must act from now how to get rid of that. So during my presentation, I will define what I mean by circular economy, why it is important, and how it is related to plastics. So everybody hearing today about the plastic pollution that has become a daily headline, and how to get rid of those plastic waste, and what are the various ways through some of my own research as well as the global research going around. What are the key points of my presentation today? So climate change is a continued pandemic. So as we see a devastating effect of the pandemic, that COVID-19, so in my opinion, this climate change is a continued pandemic, and it is just like a slow poison, and our planet is in real crisis now. And with that concept, I have to give my presentation on plastic waste. It is a global pollution problem, and this climate change also creating a lot of health problem. I will come up for that. In my presentation, I will talk about we need circular economy and we need a waste-free world, because we are creating so much of plastic waste, food waste, and that are creating a huge greenhouse gas emission. So in that concept, I will talk what is the meaning of upcycling of plastic waste. Unlike this plastic waste enter into the landfill without diverting from the landfill and utilizing that for our utilization and keeping in the earth as long as possible for several decades before it goes to landfill. Then second part, I will talk of cycling of waste biomass. And then I will talk about hybridization of the waste plastic and waste biomass to create some advanced new materials in green manufacturing sector. What I mean by green manufacturing, it might be automotive sector or it might be packaging sector. So then in that concept, I will define what is the sustainable materials or sustainable composites definition in general. Initially, when I started my research, I was thinking sustainable materials are only obtained from biological sources. So that is not true now. Definition has been changed. So sustainable materials, whether it's a polymers or composites, I will go over, it must be obtained from bioresources, recycled material, waste resources, and their hybridization. So how intelligently you hybridize the waste and with the virgin materials to make a new waste innovation. That's what the definition of sustainable materials. In that sustainable materials, I will give two examples. One is bio-based, not biodegradable, especially durable, that is reduced carbon economy, that can go for durable applications, especially in automotives, building products, and so on. And second part, I will talk about bio-based, biodegradable, which is a best solution for a single-use plastic alternatives. So that is my second part. And with that, at the end, I will give my key message. If you look into the current economy that we are continuing, this is a fossil fuel economy, is based on coal, oil, and gas. That generate more than 75% of the greenhouse gas. And if you look to the fossil fuel economy, till now, we have consumed 12 billion tons per year of carbon. Carbon is the fundamental of the materials. Whether you talk about the new materials or green materials or bio-based materials or the petro-based material or fossil fuel materials, the basic element is carbon, fourth element of the periodic table. And so we consumed in our globe about 12 billion tons of carbon per year. And that carbon is coming from gas. It is about 4,100 billion cubic meters in 2021. Coal, we got about 8 billion tons of carbon, and oil about 4 billion tons in 2021. Having said that, so consequence what? The global carbon dioxide emissions is the highest level in the history in 2021. Please look into that. And that what happens because of its global emission, there is a greenhouse gas emission relates. Now greenhouse gas emission or global warming is no more a story. It is a scientific fact. If you look into that, if you look into one of the NASA website, sorry. If you should see into the NASA website, there are two, I don't know why video is not working, but in that video, there is a blue color that relates to the cooler Earth, that is baseline from 1951 to 1980. But if you look from 1980 onwards till now, this global warming is becoming more higher and higher, and our Earth is becoming more and more warmer. So we are now passing through a warmer climate. So global emissions need to be reduced by 50% by 2030, and we must reach at net zero by 2050 in order to stay within the 1.5 degrees C limit. Why that 1.5 degrees C? That it has been defined by climate change and various agreements, because above that, it will be unsustainable and whole world will be in peril, in the health peril and several. Although we are realizing all those type of problems due to devastating effect of climate change. So greenhouse gas emission is the highest level now in 200 million years of the history. So our planet is in crisis because of climate change, biodiversity loss, which is affect your agriculture and ecosystem. The yield of the agricultural crops will go down. Plastic pollution that I will talk on, deforestation, air pollution, that is the biggest concern, health in peril. We are in dangerous situation. Even if you look into Delhi, I was reading something in the Delhi, there is a lot of gases is coming out because of the driving of the car, and people are burning the rice straw, wheat straw, all those. So people are now getting lot of health problems. So it is just one example. And water scarcity, because of this climate change, we will have water scarcity, catastrophic storm that will make the people go from one place to another place, rise of the temperature and sea level and melting of polar ice and acidification of oceans. There are so many devastating effects, and we must think how dangerous this global pandemic, that greenhouse gas emission of climate change is. So we can still prevent the most of catastrophic changes, but time is running out. So the why that's not people are realizing, but we are not realizing that slowly, but this is really happening. We must act now to drastically reduce greenhouse gas emission and change our approaches to growing food, consuming products, and managing ecosystem to avoid a dire future. So please think over that. So if you look into the market now, global, continental versus regional, we are now transforming from oil and gas-based technology, that's called, you know, oil is a global, because it is going from the global way it is moving around for the utilization by oil tank in the sea. Then gas pipeline transportation is considered as a continental type of economy. But now we are transforming from this oil and gas towards biofeedstock. That's called a bioeconomy. We have to go, there is no way out. And the whole world is working in that direction. So if the biofeedstock should be unlike the global and continental, it will be mostly regional, because one of the biomass that is grown in, let's say in Canada or in Ontario versus in British Columbia versus in California. So we have to create our bioeconomy locally, and that should be transferred globally. That's what the concept of the bio-based economy or bioeconomy. And what will happen? Because in order to decarbonize the economy, take out all old carbon and replace that by new carbon, so we have to go through bioeconomy. That's the only future. What will happen? This will reduce the fossil fuel dependency, the local availability, so it's a local economy, and safeguard of materials and energy supply. So what is low carbon economy and why to care carbon? As I told in the very beginning, carbon is the fundamental of the economy. So we have to make our low carbon. What do you mean by low carbon? That means current carbon is old carbon. We are dominated with old carbon. To replace the old carbon with the new carbon, as much replacement, then we can tell as low carbon economy it is. So low carbon economy is called bioeconomy. That is the way to go in order to decarbonize the world by 2050. So fossil fuel feedstock is called petrocarbon. We call it old carbon. It is based on hydrocarbon chemistry, CH chemistry. We are now entering into the bio-resource carbon that we call new carbon. That is called carbohydrate chemistry or CHO chemistry. But fundamental is carbon. If you go from hydrocarbon chemistry to carbohydrate chemistry, that will help in reducing the greenhouse gas, improve the carbon credit by emission of reduction credit, entering a new economy that we call bioeconomy, and it will inject more than 1,000 billion economy boost per year in order to secure both economic and environmental future. In the right hand, I have shown you now and future each grow the economy through renewables. I will add one, renewables plus waste. So if you, let's take a very brief outlook on the petroleum refinery that we are enjoying since several years that has devastating effect of climate change now. If you look into this chart diagram, in the left-hand side, if you look to the blue, 70.4% petroleum we use for, mostly for our transportations, fuel. So that gives how much economy? That is 385 billion. 4% of the petroleum is used for materials that I am going to talk today. Materials, chemicals, polymers, or rubbers. Only 4% that give a revenue of 375 billion. You can well imagine how powerful the materials in the world economy. And so that's the big thing. That doesn't mean that we have to not work on fuel. Fuel is equally important. We have to drive our cars. So both are quite important, both fuel, energy, bus, materials, so far as the economy is concerned. And another point I have written at the last end, we have enough biomass in the world. Only 3.5% of the biomass has been used by now, or we are using. We have 96.5% biomass available, land available. So making the bioeconomy a reality by 2050 is not any imagination. It's a scientific fact, and that is how the world is moving and should move. And so far, biofuels and biomaterials, I gave you the important. It's not new. If you look to the view graph, this is a New York Times, September 1925, and photo of 1933. Henry Ford was a quite visionary. He thought about that. And even the corn alcohol blended with petroleum was used, people were using that in their car. That is in 1925. So it's even see the materials. Henry Ford made the soybean plastic best parts and testing his car parts. So he was quite visionary, and you might ask, why so many years have passed, why that biomaterials or biofuels did not enter? The answer is simple. Petroleum was so cheap, people were very comfortable with that. Nobody thought about so-called catastrophic effect of greenhouse gas. Now everybody is key, everybody is interested how to get rid of the plastic waste, how to make it renewable energy. That's why we are entering into this new era. So sustainable materials or sustainable development is a triple bottom line, as everybody knows. So meet the present needs without compromise the ability of our future generations. So in the name of sustainable, what we are going to develop now, we make sure that will not affect negatively to our children or children's children. So renewables or biomaterials or biofuel is not going to do that. So in order to make a sustainable development, there are three components. It should be societally accepted, economically feasible, and environmentally quite friendly. So only when those three combined, overlap, then we tell the true sustainability, has been achieved. But another thing I want to point it out, sustainability is not a specific terminology. It is a relative terminology. How good we are from the bad. So it should go through a roadmap. If we look into make everything perfect, that will not happen. We have to go through roadmap. So then I come to rise of plastic. It is quite inevitable, and we cannot stay without plastic. Plastic has made our life so easy. Society needs it. Why? 2 million tons of plastic was made in 1950, but currently we are making 450 million tons of plastic per year today. Plastics are needed. Without plastic, life is not possible. For food packaging, to protect our food, to have a shelf life, to blood bags, to syringe, even our dress. So plastic we need. So not only that, current is 450 million tons per year for plastic, but world is going to produce 2 billion tons of plastic per year by 2050. But another point I have highlighted in the right-hand side, plastic production and incineration pump 900 million tons of greenhouse gas emission to atmosphere globally, and it will raise to 3 billion tons by 2050. It's not going away. But we must have to find out the disruptive way, how to reduce those and go to a more bioeconomy approach. So plastic waste is pandemic, leading to climate change, pollution. 1950 was the age of plastics. Before that, before the Second World War, people were relying on the natural resources. Then the Second World War created a scarcity of that. Then just like necessity is the mother of invention, the plastic invented, and from that there is no going back. They go up, 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 because it made the life of our human beings so comfortable. So, but it has led to 9 billion tons of plastic waste today. Plastic waste do not go anywhere. Whether you throw or go to landfill, it is still there. So if 9 billions we already created, and a few days back we already crossed 8 billion population, so this means each human in the globe has created 1 ton of plastic waste on average. We desperately need a second age of plastic that we call as sustainable polymers. So if you see the plastic waste, we create about 300 million tons per year, which is equivalent to the weight of the total human population. So by 2050, more plastic will be in the ocean than in the fish. In the right-hand side, I show you a view graph. It's a recent study was done by European Union, where they studied the fish from Indonesia and California. They found 1/4 of the fishes they study, they have plastics and fiber in their body. That does mean what? Once we're taking our dinner or lunch, we are taking plastics. That means we are fish. We might consume the plastic, which is quite toxic to our body. So by 2050, more plastic will be there than fish in the ocean. So new calculations by Professor Jamak from University of Georgia has told that 20 million tons to 58 million tons per year of, plastic, of those plastic will be in the ocean by 2050. You can well imagine. Now it is 10 billion. And each second, we are injecting to the environment 10,000 plastic bags and 1 garbage truck of textiles. So microplastic is a quite dangerous thing, and we need a plastic without microplastic. What is microplastic? Any plastic less than 5 millimeter in strength in your length. And sources of microplastic, I have given a very busy diagram, but you can see industrial microbeads, plastic waste dumped and leaked to the environment, and plastic used in packaging that all cause your microplastic. And microplastic is found in human blood, and very recent study this year show that microplastic in the breast, human breast milk. That means we are injecting some toxic materials to our baby, fast-born baby, once it's coming out. So you can well imagine how dangerous this microplastic to us. Microplastic are everywhere, even in the Mount Everest snow. And the time for preventing plastic pollution is long past. The time for changing the future of plastic in our world, however, is now. No waiting. We must have to move fast to save our world from this catastrophic effect of greenhouse gas emission and climate change. We must change how we design, use, and reuse our plastics. So I think scientists are developing that. I will give you a few examples, but people are really moving very strongly in this direction. So what is circular economy? The current economy is linear economy. What is the linear economy? Take, make, use, and throw. That is called linear economy. That is cradle to grave. But that is not sustainable because our population is increasing. We have a fixed area in the whole world. That cannot go on. In a room, we have 100 people or 200 people. We cannot put million people in this room exactly in the same way. If our population is increasing, we have a fixed area. Our resources is fixed. We cannot consider any waste as the waste. Waste must be a resource. That's called circular economy. Waste-free world is where the future is. So make the world, so circular economy, there is no waste. Take the waste as a new source, and waste of one industry should be raw material of another industry. So key principles of waste-free world: reuse, repair, remanufacture, and upgrade. So this is a closed-loop system, cradle to cradle, unlike cradle to grave. Waste is a feedstock. Minimize the waste. That will increase the job, reduce the greenhouse gas emission, and it will give new economic logic. And sustainable polymers, as I discussed very recently, we make this work, and we already give this concept that sustainable is no more only bioresources. Sustainable must be from renewable, recycle, and waste feedstock. And feedstock might be carbon dioxide, the gas which is going out. Nowadays, people are capturing this carbon dioxide and making some biodegradable plastic that's commercialized. People are taking carbon dioxide and utilize that in greenhouses to grow their vegetables. People are using those carbon dioxide and making various industrial products. So your biomass or waste or natural or waste residue or carbon dioxide should be your feedstock. And then you make a supply. And again, the manufacturing should also be green processing. You should not use a lot of petroleum there. You use bio-renewable energy. Then go for applications. It might be a car parts, it might be a drinking bottle, or it might be 3D printed products. And after that, it must be collected and sorted out. If we take something is biodegradable, it must have the proper environment. Not that you can put anywhere this will be biodegradable. If we take recycle, we should have a recycling facilities. Then again, the bio-based materials can again be regenerated through your photosynthesis, and again you synthesize. So that cycle is very important. So upcycling plastic, that is the waste plastic, recycled plastic, biomass, for high-value composites. What is a composite? You know what is plastics? Everybody uses composites. Is the combination of plastic and some filler. That filler material might be any fiber, natural fiber like hemp fiber or jute fiber or some of the glass fiber. So those are called filler. Once you take a plastic plus fiber or filler, that's called a composites. Composites generally very stiff material. So not only agro residue or plastic is a waste, another biggest waste is the food waste. 1/3 of the food waste per year, that equivalent to 1.3 billion tons amount of that food waste, that is about $750 billion. So we are wasting those food waste. So that means we are throwing $700 billion per year. That adds 8% carbon greenhouse gas. Because food, if you enter into the inside, they get a methane. Methane is quite 12 times, or some people do 20 times more heavier greenhouse gas, dangerous greenhouse gas than carbon dioxide. So we also developed some work on composites. Composites means plastic plus bioresources. Composites, you might take a plastic from virgin or combination of plastic waste plus waste plastic, virgin plastic, and all the filler might be the combination of the traditional filler plus waste filler, which are agro residues like wheat straw, rice straw. Don't burn those. Utilize those as a filler material. Or any food waste, I will give you one example. Utilize that filler materials in the plastic and get a new innovative product. I will give you a few examples. So this is the first example that went from my lab. We use the plastics, unlike entering into the landfilling, we take with that, and it's not a magic science or it's not a very big science. Just taking the waste plastic mixed with agro residues And in Ontario, we have a lot of agro-residue, wheat straw, not rice straw in Ontario, wheat straw, corn stovers type of things, and mixed with our waste plastic and develop those consumer products. You can find those products in storage, bio-beans we call, in all home hardwares in Canada. And we developed some flower pot, which was originally made from virgin polypropylene, but it is made from waste plastic and biomass, and now this is sold in Kroger's and Lowe's. And my second part of this presentation, I want to introduce black is the new green. What is the meaning of that? If you look to the terra petra means a black soil. Now, to the 21st century world, it is a save of carbon sequestration. If you look into the left-hand side, once this biomass or anything entering into the soil, and they are mixing and mixing those black carbon, were mixing with the soil, we call it terra petra, so which is about more fertile. So people are using that. This technique of using charcoal to improve the fertility of soils originated in the Amazon basin at least 7,000 years back. So I will tell, for the first time in the history of the world, I think University of Guelph thought to use those as a filler materials in the composites, and that composites today is commercialized by Ford. I will give you a few examples. We did some pyrolysis. It's not a new technology, and we take pyrolyzed biomass, pyrolyzed waste. It is not required to take a good biomass. Take some waste biomass. Take some very much waste, which is not have no value. So what is pyrolysis? Heating of waste biomass or waste food residues in absence of oxygen. And that creates two things, bio-oil, biochar, and biogas. Originally, this pyrolysis was targeted to make first pyrolysis to make a bio-oil, and that bio-oil to replace the petroleum refinery. But the way that we thought, let's go for slow pyrolysis, that research is going on in the whole world, but in my thought, I thought, let's try to utilize those char, which is basically going to low-value application in soil fertility. Can we make it high-value application? We developed a lot of those high-value biocarbon that we define. Unlike biochar, we call it now biocarbon because it's a material, it is going for applications now. The research that I first initiated in Guelph about 12 or 14 years back, I'm very glad that this area is well circulated throughout the world. Now this so-called biocarbon by pyrolysis of waste is being used for biomaterials, bioenergy, and several other environmental remediations. So I'll give you one example because of the time. I'll give one example here. I use the biocarbon from the waste biomass, and I have given some example in the left-hand side. Then we go for normal pyrolysis by 600, 900, collected the carbonized gas, carbonized biomass, make some surface treatment and make the particle size, the biocarbon, and we mixed with polypropylene, which is a traditional polymer, as well as recycled polypropylene, extruded that, and then injection molded. You can see the extruded pellets, then it go to injection molding and we make a car part. I will give you a second example. This is, we developed about 8 or 9 patents on this biocarbon technology for various applications. If you know, in a car, there are about 80,000 different parts, whether it's a bumper of a car, or handle of a car, or a roof of a car, or several things. So one of our technology recently was commercialized by Ford Motor Company, and what they did, because of the collaboration with McDonald's and Ford, they took the coffee shop. We are getting billions of coffee shop, which is the skin of the coffee bean. They took the McDonald's coffee shop and mixed with the plastics and developed this headlamp housing of a car. Headlamp housing means two sides of the car where the lamp is located, and this is about 2.5 kg. So we reduce the weight by about 20%. As you know, if you reduce the weight of the car, then there will be fuel efficiency. That means you are reducing the amount of petroleum. And that's just a simple examples. So according to, this was done by strong university and industry collaboration. Ford is the end user, competitive green technology, compounding industry in the Ontario, and Bharat Lighting is injection molding in Michigan. According to the report, the resulting components of the University of Guelph technology made 20% lighter and requires up to 25% less energy during the molding process. What I told in my sustainable material definition, your energy should also be less, not only materials. So in this way, we are working a number of automotive industry across the world in developing various parts of the car and packaging materials. And then the rest part of the presentation will be focused on single-use plastic alternatives. I talked about bio-based, recyclable, non-biodegradable. That's a reduced carbon economy. They are not biodegradable, but since we are using bioresources, even at the end of the life, that carbon will be sequestered. That is called reduced carbon economy. All are not required to be biodegradable. As you know, Environmental Minister of Canada announced single-use plastic ban as early as 2021. They were very aspirant to do that. The government said it considered plastic that are harmful to the environment, hard to recycle, and whether they are readily available alternatives. That's a very important point. It's not single-use plastic ban is important here in Canada, United Nations, Germany, China, and other countries, India, in several cities, several places, the single-use ban is already been effective. I will give you one example. In the right-hand side, so initially Canadian government decided to take 6 parts from out of the picture, not to use this. Number one, plastic grocery checkout bags. That bags we always use. Straws. Third is stir sticks. We use and stir our coffee or anything. 6-pack rings. That's we buy our beers and cutlery and take-out containers. So then I will give you example what government announced in December 20 last year. So I will give you one example. One of the product is cutlery. Cutlery, if you imagine one cutlery, about 40 billion cutlery pieces in North America, US and Canada, per year. And it is about 100 billion globally per year. Made up of polystyrene is a dangerous material, dangerous polymer. Styrene is carcinogenic. And polypropylene. We cannot sustain those. And that is, I will show you in one of my videos how one of the newest discovery in our university center created some biodegradable straw that we claim it will be degraded in various environments, including marine and industrial home like that. Global Plastics Pollution Agreement, it was a historic moment on March 2nd, 2022 meeting by United Nations. The United Nations Environmental Agency brings representatives of 139 countries, member states of United Nations, business, civil society, and other stakeholders to agree on policies to address world's most pressing environmental challenges at the 5th session that took place in Nairobi in March 2022. After that, Canada announced. I will show you in my next slide. So once you change the alternative, you must think about full life cycle of the plastics. You might get alternative, but it should have end of life. It should not create any waste. Provide a global common vision or harmonized standards. As I told, bioeconomy is not global. It is a regional. But regional can be transmitted globally by taking similar technology, by using different biomass from different regions of the whole world. This is key moment in the effort of eliminate plastic waste and pollution on a global basis. Then the very recent, December 2022, Canada to ban production, import of single-use plastic based on the announcement by the Canada's environmental minister on June 20, 2022, except some of the medical needs. Those are some exceptions, even if you can use single-use plastic unless we have 100% replacement. Over the next 10 years, this Canadian ban will result in the estimated elimination of over 1.3 million tons of plastic waste and more than 22,000 tons of plastic pollution, that is greenhouse gas reduction, will be reduced. So this is another example that we developed in our university. is a compostable coffee pod invented our university. So, because coffee is a very well-known drink for everybody. And I always joke, Canadian takes more coffee than Americans. And single-serve coffee has become a fashion nowadays because we need different taste. So earlier days when I was young, I was taking a Nescafe in a very big packet. We were taking every day or using again and again and again. But people need different taste. So single-use coffee market grows up. In 2018, the market was $1 billion per year, whereas in America it's $5 billion per year. So once upon a time, I was approached by a company. So I want to tell you another statistics in the very right-hand side I have written. In North America, we use 16 billion single-serve coffee pots that can well the whole world 17 times. Can you imagine how much waste it is? None of them is going to recycle. Everything is going to the landfill and create methane gas, which is more dangerous greenhouse gas emission. All are waste, and they are creating devastating greenhouse gas. Coffee is the second most traded commodity globally next to crude oil. Another statistics tell 39,000 capsules produced every minute in the world. Every minute. And what I was approached by a company in Toronto, can we make biodegradable coffee pot? But the bottom line that it should not be more costly because no business, you might take a green or bio, but nobody give you a single cents more. And there is no government incentives for bio-based materials. It was a big challenge, but once upon a time I visited their industry, I found that everywhere, whether you make a company in Toronto or Calgary or British Columbia, you have to import the coffee bean. And in order to make a coffee, you have to freshly brew that. Then the skin is waste. Every day, that company was bringing about 2 truckloads of coffee shop, and they are going basically to the landfilling. This is a beautiful waste. Why I tell you it's a beautiful waste? It's not contaminated, nothing. It's a coffee bean and taking out. So I thought this is zero cost. I took those chaff and mixed with my biodegradable plastic, and surprisingly, within 13 months of work, that was successful, and the final product was cost competitive, and it went to the market. That's the first compostable coffee pot, certified compostable coffee pot developed at the University of Guelph. An example of circular economy. Why I call circular economy? Take the waste from the coffee industry and again utilize that for the coffee industry. That's called circularity. And it is being commercialized in US, Canada, South America, Mexico, and beyond. If you see the very bottom, there are 2 compost coffee cup examples. The left-hand side is made from polypropylene, is the ring, and the mesh is made from PET. And the right-hand side, we made from coffee sap-based biodegradable one, and that is being industrial composting condition is degraded 100%, 90% above. And this is converted to carbon dioxide water without leaving any toxic materials in the soil. So that was a win-win situation. And it was an Ontario-made compostable success story. It happened because of the government, university, and industry collaboration. By now, with a very short period, there are 2 billion coffee pots with a commercial name per pot has been commercialized. This milestone represents diversion of 3,000 tons of plastic single-serve coffee pots from landfill in Canada. Well-known brands, President's Choice, Maxwell House, now Ethical Beans, and so on. They already commercialized, and Bioproducts Discovery Development Center at the university made the technology, and government funding, and resin compounding industry in Ontario, and end user is Ontario, and it was commercially successful. And one of our newest discovery that we made recently, because, you know, I want to tell you one thing, people came biodegradable. Biodegradable is a very irresponsibly claimed by anybody. You need to remember, once somebody tell biodegradable, or somebody give a 99% biodegradable. This is all nonsense. This is not true. Nothing called 99% biodegradable. That's a greenwashing. Once somebody tell whether biodegradable in your industrial composting, or biodegradable on a home composting situation, or biodegradable in the soil, or biodegradable in the marine, or biodegradable in various environments. That must be defined. If somebody tells biodegradable, that's not going to happen. Suppose I being an inventor, if I tell my product is biodegradable, that's not going to be accepted in the commercial market. It must be certified by third party. So one of the examples I showed previously, it was certified by Biodegradable Polymer Institute, non-profit organization, and they tested independently and certified, yes, this is 100% biodegradable. That's called industrial compostable. So there is nothing called biodegradable. Whether it's industrial compostable, or home compostable, or marine degradable, or it's a combination of home compostable and marine biodegradable. So very recently, our newest discovery, we made it. So we think we already made some testing and already made several prototypes. It is under testing now. And it's a K-cup as well as espresso cup. And here we need a quite barrier properties. And we claim this type of product is going to be biodegradable in the soil, biodegradable in the marine environment, and biodegradable in the industrial composting. So my first invention I showed, this is only industrial compostable, not marine degradable. But this is a newest discovery where we are trying to make our technology universal type of biodegradable. And another thing we need to remember, once we are developing some bio-based materials, we should be very careful for the cost. So although the initial cost of the bioplastic is more than the petroleum-based plastic, because bioplastic is new, and petroleum plastic is already 100 and several hundred years of old. We cannot compare a small boy with a 100 years old or 70 years old boy. So that means this area is growing, there is a lot of demand, then the production will grow up. In between that, we have to take a lot of statistics, lot of data management, and in one of the newest discovery what we made, we take a commercial coffee pot, which is about 6 mm in thickness, by additive manufacturing and by data management, that's called artificial intelligence, we correlated our research findings and we reduced the thickness from 0.6 to 0.4, having the same performance. So we reduced the weight of a single product by 33%. Final product you are using is less material, so in that way you can have a cost savings. So although we have proved some biodegradability, but that must be certified by a third-party organization that we call at TUV Australia, that is undergoing. Sorry. Then, based on our new discovery, we made various nanostructure. I am not going to discuss all those fundamental science here, but I just want to tell you, by a nanostructure technology, we developed toughened biodegradable materials, and we made high-field biocomposites. What do we mean by biocomposites? We take either biomass or food waste residues like coffee sap or tomato skin or tea dust powder like that, and we developed a number of industrial products, whether it is a compostable film and some of the recycle-based container for the food packaging, and we also developed biodegradable clip for the greenhouse gases for the tomato clipping, and some biodegradable straw, and also we developed some home compostable cutlery recently. So I would like to show one example how it was very exciting that we call our biodegradable cutlery that in North America. I will try to see this video if you can. So you can see something you might develop in your industry, in your own laboratory, but once it go for industrialization, you get a lot of problems. You might do in a small scale, but that may not happen in the large scale. So you can see how some laboratory base that we call it a biodegradable various environment in a marine degradation, home compostable, and it is expected to be soil biodegradable because 40 billion of those cutlery being used in North America. And possibly, if this type of things, it will make a real innovation in North America because none of the cutlery today, we have some industrial compostable, but it's a marine degradable, it's a possibly home compostable, and industrial compostable that we call this cutlery. That was done in industry scale, And after several iterations with the industry, and we were very excited that this type of product may enter into the market very soon. I do not know how soon it is, but it has already been testified, and several big brands in Canada and USA have already tested, and they're quite happy with this discovery, and that might go. So this is one example. And at the end, I would like to highlight one thing. It is not me or you or any forward-looking people thinking. Even in the 2018 Economics Nobel Prize goes to the same concept that I talked today. Integrating innovation on climate. You must make a new technology. You have to innovate, whether renewable technology or biotechnology or whatever. And it must be tagged with reduced climate change. Then only you can talk economic growth. Without innovation and without climate change aspect, the sustainability economy is not at all possible. So somebody tell, I don't believe in greenhouse gas, I have not seen that. So those are the things I don't want to comment, but greenhouse gas emission is a real problem, is really fatal, and is affecting to the human health. So transition to a low carbon economy requires circularity. Don't think anything waste. Take the waste and consider as your next resources. So key message, plastics are inevitable, nothing is waste. Value-added materials can be developed. Bioplastic is maybe the single-use plastic alternatives. Government tax, polluter, carbon tax, those are the other things need to be discussed. A transition to low carbon is required. Circularity means zero waste, reduced greenhouse gas, and disruptive technology is required. Machine learning, artificial intelligence, and community engagement is very important. And collaboration is also key driver, as I already said. With that, I'd like to thank you, lot of funding agency, and especially to RSC for Miroslaw lecture today. And finally, I am thankful to all the people who work very hard in my research group. And several people are behind the work, and I am speaking. So thank you and for your patience hearing. And we might have another 10 minutes. If any question answer, I would love to answer.
Thank you very much. Dr. Mohanty, the Miroslaw medal. So if we have time for some questions, and Lawrence at the end, maybe we should have somebody else that's, with a microphone. I can go. But you know, one thing that scared me is I drink 15 cups of coffee in my room, so I'm not sure if this was part of it or not. So Lawrence just there, and
okay, thank you very much for a wonderful talk. The circular economy I've heard very much. By the way, my name is Lawrence Maisak. I was elected to the Academy in 1986, Academy of Science. I'm a past president of the Academy of Science. And in the 1980s, early 90s, the Royal Society had what was called the Global Change Program, which was funded by the federal government at the time. And I think its main success was producing information and outreach to the public about how important global change. We didn't call it climate change, we called it global change. So I'm just wondering, Dr. Mohanty, whether you think the Royal Society could be banded together to deal with this long-term pandemic by emphasizing the ideas, reaching out to the public about the ideas you've talked about today, just as the Royal Society has been very successful during the COVID time. So that is not really a question, I guess it's a challenge to you to get the Royal Society together on this issue.
Thank you very much, and this will be a great honor, and if this sort of things can be taught to various people and various lectures. And one of the important things I could not cover up, this bioeconomy or importance of bioeconomy must be circulated or taught very nicely even from the school level. So education is lagged. Even a recent study was done by in a study called Soybean Association United States. United States is more advanced country in the world. Even 75% people they study do not know what is bio-based materials is. They do not know what bioeconomy is. So education and and giving this sort of idea and making the government and even in the children, because most of the parents hear their children in the house. So those concepts must be developed, and that type of dissipation of knowledge of this new economy to decarbonize the economy should be there. And thank you very much for this comment, and I 100% support of this.
Okay, thank you. We have several questions, so I will move on.
Thank you very much, Professor Marie-Claire Cordonnier-Seger. I serve as Executive Secretary of the Climate Law and Governance Initiative to the COP27 in Sharm el-Sheikh and now the COP28 in Dubai. And I'm Senior Director of the Center for International State Involvement Law, but I suppose probably most relevant, I guess I was elected yesterday to the Academy of Social Sciences. And I was, so just quickly, you mentioned several legal mechanisms in your talk. And I was fascinated by the way you wove it through. Thank you very much. You mentioned in particular taxes, carbon taxes, incentives, subsidies, government funding, and then you also mentioned bans. And of course, we're all working on a plastics treaty through the UNEA, which we do think is going to be probably part of encouraging bans. And in some cases, that's what you need. You know, it's too late for, oh, please change this. It's time to say, no, this is obsolete. End it now. We have the alternatives available. We can develop them. That's how we succeeded with the Montreal Protocol. I'd love to hear your thoughts on how all of these measures could come together and what lawyers and legal scholars can do to help.
Absolutely, yeah. Thank you for your comment, and I think alternative is plastic important. So.
Thank you very much for your talk. It was fascinating. I'm Alice Aiken. I'm the Vice President for Research and Innovation at Dalhousie University. And my question is just a really practical one. Is your lab where you're producing all of the bioplastics, is it powered by clean energy?
What is that question?
Is it powered by clean energy, your lab?
No, sorry. This is not the clean. So what we did, although because we cannot use a clean energy to make our products. But what our idea is that if we develop some product, if you can reduce just one of the example I gave you, in the port of one of the part they developed from our technology, they reduce the energy value from the existing energy by 25%. So how the new materials can have a reduced energy consumption, that's what my lab does. So far, utilizing the bioenergy and making that is another aspect that needs to be taken care of the manufacturer. Whatever we do in the existing energy, that can be done by the renewable energy, if that is what your question.
Thank you, Dr. Mohanty. My question is also more practical one. In many cities, and I can say I'm Digvir Jais from University of Manitoba in Winnipeg, a lot of recycling programs have been put in place. Material is collected, but the recycling capability is not there, so it goes to one place and then they take it to the dump, rather than it used to go at one place in the first place. So what can be done, and maybe the legal scholars were asking, what could be done to force the cities to develop proper recycling capabilities?
Yeah, that's an outstanding question. So as I already told in my presentation, although we tell our product is recyclable, but if you do not have the recycle facilities, it is not of no meaning. So many plastic they told you recyclable, only 9% of the plastic are recyclable. Rest are either they are going to landfill because of the lack of facilities, number one. Number two, there is some mixed plastic. It is not economical to recycle that. So that's why, so in answering your question, that type of things must be developed by government. They should create some regional-based recycling facilities in order to make it. Because I will give you a very simple practical example. Many recycling industry I talked, they told after recycling, the cost of our product is becoming more than the virgin polymer. So nobody is going to take from us. So unless government make a policy that the Dow, DuPont, and big industry should be responsible, or they have to make their recycling facilities to make their product recyclable, that recycling is not going to happen. So I think in that directions, now the world is moving. Another thing, because of the consciousness of recycled waste plastic, people are collecting these waste plastic and going to valorization by making some composites and other applications, and people are also going to chemical recycling. That area is going very, very strongly, and just like a speed of light throughout the world now. But that's excellent question.
Hi, I'm Janet Elliott from University of Alberta, Chemical Materials Engineering. I thought your talk's a really impressive engineering and really lots of wonderful things. One of the coffee pod things I'm disappointed with when I go to buy compostable coffee pods is that they're not airtight, so they need to be in a non-biodegradable, compostable packaging. I'm wondering if your lab is going to work on that next, the packaging around the compostable pod.
Yeah, that's a very practical, and I also faced that. Even if we develop some compostable coffee pod, and some municipality tell no, we cannot accept those in our system. And those type, if I give a lot of examples of Italian story, just like I gave you an example of regional versus continental versus global, unless government is talking that we want to ban single-use plastic, that's perfect. I'm 100% supportive of that. But another thing we must think, and policy people must think, that should be some regional-based composting facilities. Suppose Guelph, I am from Guelph, and Waterloo, and McMaster. So there is a regional land, and those type of things are quite successful in European countries. So that must have an appropriate environment to do that. So people will be educated to put their biodegradable pot in the green bin or whatever bin, and that should be collected and that should go. And that's, to be very honest, that's depending beyond the scope of a professor like me. It must be taken care of by the government, by policymakers, and they have to, and technologically and we made it successful, and it is certified globally. If European people are accepting it, why Canadians we cannot do that? That's a matter of long debate and policy, lawmakers, policy, those are the things, because this is a serious issue. We can ban plastic, but unless we have alternative materials are there. But how to dispose of those alternative materials in appropriate environment, that is not there.
Thank you very much. We'll have two more questions, and then we'll take these two on top. But there you go.
Yes, Marcus Gehring. I'm visiting from the University of Cambridge, and I'm also one of the lawyers. In the European Union, we've banned single-use plastics, and we've included fishing nets.
Yes.
And there was a particular challenge by the industry saying we can't use biodegradable plastics for fishing nets because you need particular strength. But with your nanotechnology, can you think that some of your products could maybe be used for fishing nets and solve that intangible problem? Thank you.
Yeah, that's another important and exciting questions. So now the one thing that I highlighted today, it is a single-use plastic alternatives. That means whose lifetime is few seconds to few weeks. So that's easy, but so far as fishing net, as you rightly pointed out, they are mostly made from nylon, this high-strength polymer. And it is possible to make it, but to make it biodegradable, it is technically possible, but it may not be cost competitive. And that technology, to the best of my knowledge, is not very near, because we have so many other problems. Because single-use plastic is about 50% of the total plastic. If that problem is solved, in my opinion, there's a huge reduction in greenhouse gas emission. And fishing net, to the best of my knowledge now, it is a very high-strength polymer. They are a durable polymer. They are staying inside the ocean that need a particular durability, not that you put something inside the fishing in the ocean and they will break down. So that technology is not yet here. But I am sure people will find out that innovations. And for me, I have not done that.
Thank you. There's no...
Thank you very much. Vijay Raghavan from Bioresource Engineering. Congratulate you for a wonderful talk to integrate science, technology, and the societal systems. I've been with the One Health concepts being discussed the whole week. I've submerged in that, hearing a lot of things. So One Health is something which is being pushed to look at globally for our planet, as you indicated in many of the aspects. So I'm sitting here and thinking how you would see that all the things that you talked about to make the connection to the One Health concept. We need that now. So I'd like to hear your reaction to that, please.
Can you repeat?
One Health concept is what is being looked at now, looking at the philosophical approaches of indigenous people and the present way of whenever we try to better ourselves, we look at destroying the ecosystems and the environment. So how do we actually reverse that? And certainly the points that you made are very appropriate to be integrated into the One Health concept. So I was wondering whether you were thinking in those lines.
So if I understand your question clearly, and to be very honest, I'm not very clear on your question. What I understand, if I am incorrect, please correct me. Are you asking me how this technology will be used by many industry?
No, the discussions that we have had the very first day on Wednesday, Thursday, for example. So One Health connects to various disciplines.
Yeah.
So whether it is science, the arts, humanities, and the technology. So certainly yours will fit into that. So government policies should integrate these aspects into that general, so that our Canadian concept of One Health moves forward in a circular economy framework. So that's what I'm...
Okay, that's now I understand. Yes, you are right. So the topic that I am talking about, this is interfacing the science, society, and also policy. So I think the topic that I am talking, that can be a very good part of One Health program that you are talking about. And such type of subject, whether this biomaterials or bioenergy, and that will be an important component of the One Health progress. I strongly think about your vision on that, integration of science with the community, integration of the science with the society, and integration of the science with the policymakers. That can make this type of technology to move faster and can be really effective to the Canada and Canadians.
Thank you.
Thank you. But excellent question. Thank you very much.
No,
and I like.
Sorry, there's one more question at the end. Ask your question.
Good morning. This is AJ Delay from University of Saskatchewan. I was a winner of the Romanowski award last year, but couldn't give the talk to because of the COVID-19. And I'm very grateful to Royal Society for that, for the same award. I really enjoyed your talk, Professor Mohanty, and I just wanted to have a quick question. Hopefully you have a quick answer as well. 1/3 of food is wasted in the world. In North America, we have 5% people consuming about 20% of world food. And globally, about $1.3 billion goes to landfill because you can't consume them. And that emits about 8% of world's greenhouse gas. So can you please comment on what we can do with the food waste in order to improve the circular economy as well as reduce the greenhouse gas emission?
Okay. Thank you, Professor Dalai, and I am really inspired by you to apply for this award. So I must give my sincere thanks to you, and I am also admired by your work on bioenergy, and you are also one of the Miroslaw Romanowski award winner last year. Yes. In order to answer your question, as I already pointed out, and you rightfully pointed out, 1/3 of the food are being wasted in the globally, and that contribute to 8% of your greenhouse gas emission. And some of the examples I gave, there are certain food waste which is called post-industrial food waste. And another food waste is called post-consumer food waste. And another food waste is called mostly which is contaminated with various things. It is very difficult to separate it out. As you know, so post-industrial food waste is easy for logistic of collection. Just like I gave you an example of coffee chaff, is a post-industrial food waste, and it was going to the landfilling. And we create about 2 billion tons of coffee chaff around the world, and 99% is going to landfill. So in the regional industry can be used. I proved through the technology, coffee sand can be used as a filler in composite materials. One can use up to 30%. They can reduce the use of plastic by 30%, number one. Number two, some of the wet biomass, just like you are working on this, spent coffee ground, as for example. So your Tim Horton and Starbucks and many industries throw all their spent coffee ground. It's a wet condition. This contains about 70% moisture. So people are developing technology by hydrothermal pyrolysis, that you are also working on, and try to carbonize that, and they are finding the applications. And some people are also taking the wet biomass, and those type of food waste are easy to make valorization. But the other food waste that you are talking, which is contaminated with several things, those type of things can go straight forward pyrolysis to make energy. So people are doing, but very few industry are coming out, have come out of this food waste valorization, especially post-consumer food waste.
Thank you very much. I think we'll have to end the discussion now. So please, again, congratulate the Miroslaw Romanowski's medal last year. Yeah, I said 2022, it's 2021. And thank you very much for a wonderful talk. Thank you.
Thank you very much. And thank you, everybody, for listening.